2 precision munitions, costing less than a tank, neutralized a strategic Russian power grid built over decades to twisted wreckage. At 22:18 hours, deep inside a HIMARS launcher near the contested border, 3 of my operators held their breath. From outside, the 16-ton vehicle appeared completely static in an open field, but inside, every targeting system was armed. Through their headsets, the final strike order they expected all day finally echoed. Fire mission. Fire. There is no hesitation, no tactical debate. Under 50 kilometers away, the Belgorod thermal generation hub and its massive substation fed power and vital and utilities directly to an entire enemy city. In mere seconds, we would launch 2 precision rockets into the air, flying towards their destination to cut their power grid completely. It took just 4 minutes since our HIMARS unit had deployed at this firing position. Jack slammed down, stabilizing in wet earth, securing the heavy combat platform until it felt anchored directly to bedrock. The diesel engine kept idling low, primed to displace the second, the last rocket clears the launch pod. The commander never looked away from the console, checking the tactical targeting computer glowing in the dim cabin. He verified the encrypted satellite coordinates carefully. Our precise launcher coordinates, wind speed, air density, and altitude were calculated instantly. He knew protocol. Once we initiate launch, we will have less than 90 seconds to displace before enemy counter battery fire begins walking shells back along our trajectory. This weapon system leaves nothing to chance. The digital brain processes every critical variable, including precise coordinates, launcher positioning, and weather telemetry. Our system computes the precise launch, azimuth, and flight time. The tactical plan tonight is absolute and unyielding. 2 GMLRS rockets with separate trajectories timed for a simultaneous strike on the power grid. Inside our launchers, these heavy steel cylinders carry 90 kilograms of high explosives each. They are not dumb weapons. Every round is micro-guided, using GPS tracking and an internal inertial measurement system with calibrated navigational sensors, giving a circular error deviation of 15 meters in active combat. If signals are jammed or if they fade, onboard systems still track every tiny vibration, every slight tilt, every physical drift, pulling the missile back to its target like an unseen hand. For my crew, the entire machine-driven process is reduced to a simple act. My artillerist monitors status indicators, breathes, and depresses the launch switch. Our automated systems handle the rest. He is merely the catalyst. At 22:19, our first rocket roars from the pod with nearly 8 Gs of acceleration. Instantly, the exhaust flame turns our steel deflector plate into a blinding flash of daylight. The launch vehicle shudders violently against its stabilizers as the rocket tears into the sky. Within seconds, the rocket is already exceeding 3,700 kilometers per hour. 15 seconds later, second rocket follows, trailing its own deafening roar across the area. The moment those weapon tubes are empty, my operators cease being artillerymen, morphing into escape drivers, fleeing the launch site. The jacks retract with a metallic whine. My driver slams into gear. In under 90 seconds, the launchers had cleared the zone, vacating the launch site immediately, leaving only deep tracks in wet soil and the bitter scent of spent propellant. Meanwhile, the enemy power plant operated through the night as usual, pumping hundreds of megawatts of electricity across transmission lines. Thousands of liters of dielectric oil surged through transformers and high-voltage arrays. The enemy had no idea threats were inbound. A pair of guided rockets was inbound, arcing upward like pillars of fire, as ascending their guidance systems remained fully operational. Micro-steering fins executed constant corrections. The GPS receiver locked onto several satellites simultaneously. The onboard guidance computer cross-referencing targeted coordinates with actual real-time telemetry. The lead missile surged to 14 kilometers. At that altitude, high above ground-level clutter, the GPS signals were incredibly strong. Every single second, the weapon mapped its location against satellite data, measuring it against the designated flight path, correcting course instantly to stay true. But reliance wasn't solely on GPS. Inside a reinforced nose cone, the internal tracking unit survived violent vibration and acceleration, tracking angular velocities and linear shifts, calculating every micro deviation the flight was subjected to. Even if the enemy saturated the sky with heavy jamming, our weapon had already mapped its own trajectory. It knew precisely its degree of pitch roll, and you're automatically correcting course. These munitions do not fly in simple, straight lines like bullets. Their paths are mathematically mapped to exploit the surrounding landscape using tactical terrain masking. Where the geography permits, they skim low, hugging the Earth's contours using hills, ridgelines, and natural elevation as radar-blocking shields against radar. The first threat approached from the northwest, the second from the northeast. A split-vector tactic designed to force Russian air defenses to divide their attention. Flying over 3,700 kilometers hourly, the tactical window measured not in minutes but in heartbeats. At 22:19, Russian early warning radar finally picked up the threat. The 66th Air Defense Regiment held responsibility for the sector. Its network deployed a potent S-400 radar 15 kilometers from the plant. That system scanned out past 400 kilometers. It saw two fast-moving profiles closing fast from the Ukrainian side. Yet detection never guarantees an end of two. Intercept. The GMLRS rockets had been engineered with a low radar cross-section, not like stealth aircraft, but more like a large bird on a scope. They flew low, slipping in and out of ground clutter. S-400 sensors would catch a glimpse, lose track, reacquire them, and each time they vanished, the fire control computers had to recalculate their flight path. Every second of delay meant another kilometer gained by those rockets. On green, phosphor screens inside the command vehicle. The traces blinked like ghosts, appearing, fading, appearing again. The software struggled to build a continuous track. By the time it secured a lock, the incoming warheads were already dangerously close to the target. With barely 30 seconds remaining before impact the site, air defenders played their final card. Two 48 N6 interceptors launched from their rails, each carrying a 65-kilogram fragmentation warhead designed to detonate near the threat and shred it with high-velocity debris. On paper, these interceptors could fly at Mach 6 over 7,000 kilometers hourly, engaging multiple targets simultaneously. In real combat, they faced a fatal math problem against threats like cruise missiles or tactical aircraft. The system demands at least 60 seconds of tracking telemetry to calculate a high-probability intercept solution. Tonight, operators had barely 45 seconds. It was like facing a final math exam, ordered to solve it in half the time, with the clock already ticking down. As the 48 N6s accelerated, the GMLRS rockets entered terminal phase. They did not simply dive, they began executing rapid, evasive maneuvers, micro-adjustments every 80 fraction of a second. Their trajectory became a jagged line instead of a clean arc, shifting constantly, just enough to ruin the S-400's predictions. The defensive interceptors passed within 200 meters their targets. To an observer, that seems close, but to a guidance computer tracking an object moving at over 1,000 meters per second, it was a miss. The double-axis tactic compounded the issue. One rocket from the northwest, another from the northeast. The system had to split its tracking resources, shift radar sectors, share vital processing power, losing DAS power, operational efficiency. This is classic saturation through complexity, not sheer in numbers, but by overloading the system beyond what its timeline permitted. With less than 20 seconds remaining, it was the turn of the final defensive screen around Belgorod. 2 Panzer S-1 systems swung their search radars toward the facility, then elevated their weapon turrets. These platforms were designed specifically for threats like these: drones, cruise missiles, fast, low-altitude rockets. Each Panzer could deploy rapid reaction missiles or open up with twin 30mm cannons at up to 5,000 rounds per minute, creating a wall of exploding shrapnel. Tonight, the tactical choice was rapid-fire guns. Tracers stitched the night arcing upward in orange streaks, but speed favored the attack. The guided rockets were descending at over 1,000 meters per second, burning through entire kilometers in the time it takes an air defense operator to blink. Crews were forced to predict where the enemy pouch incoming rockets would be within a fraction of a second. They failed. Late detonations blossomed far behind the targeted warheads, useless tracers, painting glowing arcs in the air, but hitting nothing. Their last line of tactical defense had fired. It just missed entirely. The weapons kept falling unchecked. At 22:21, guided missiles struck the main generation facility of the plant. It did not detonate on contact. The warhead at its tip was a specialized shaped charge, a PBX-9 composition coupled to a reversed copper cone lining engineered to be wrapped in a fragmentation sleeve. At detonation, the payload crushed the copper cone inward and hurls it forward as molten slug at 9,000 meters per second. This kinetic jet punches through up to 0.9 meters of concrete or 0.6 meters of steel under peak conditions. This sequence is brutally simple. First, the shaped charge bores through the outer fortification. Next, a fraction of a second later, the fragmentation sleeve disgorges thousands of high-velocity fragments into the void behind that entry point. Inside vehicles that shreds critical machinery. Inside a power plant, it shreds delicate control systems, high-pressure pipes, busbars, and structural columns. The warhead's lethal envelope in enclosed structures is 15 meters lethal footprint to obliterate command decks, switchgear halls, and valve manifolds with one strike. Before launch, the crews selected their fusing delay mode, avoiding instant impact, bypassing airburst. For this target, we needed penetration directly through heavy bulkheads before internal detonation. Inside, the lead missile hit precisely. It breached the reinforced concrete, pierced the steel shielding, and detonated deep within the primary generator's core. That explosion immediately ruptured the main armored transformer housings holding thousands of liters of dielectric oil, turning pressurized fluid into combustible aerosol, exposing it directly to violent electrical arcs carrying tens of thousands of volts. Ignition was instantaneous. The dielectric coolant, meant to insulate systems, transformed into a highly violent accelerant. Fire swept through heavy cable conduits and runs. Arcs bridged ruptured power lines like blinding high-voltage arcs, igniting every combustible element. Within seconds, the whole generation hall immediately transitioned from a nominal operations to an industrial furnace. Heavy toxic smoke, violent plasma fires, and epasma fires. Storm of shrapnel shredding everything. It was no longer a functional asset. It was self-feeding, tactical bomb, consuming its own fuel. Precisely 15 seconds after the first initial strike, the second missile arrived. It targeted the primary control facility, armed with a delayed warhead. This round breached the outer concrete facade, cleared internal firewalls, and detonated inside the SCADA room, the nerve center capable of triggering emergency overrides and defensive automation. This was no tactical coincidence. The timing was highly deliberate. Our strategists planned this sequence precisely. First, destroy key transformers initiating catastrophic fires, fires triggering cascading structural failures. Phase 2. Second, kinetic impact, obliterating the command node that could have managed to isolate critical sectors, dump loads, or initiate emergency system shutdowns. Without automated overrides and centralized command, target was left to burn unchecked. In less than 30 seconds, this dual strike did not just smash hardware. It neutralized the personnel and systems that could have managed the crisis, a complex engineered to process massive flows. Power and thermal load lost all coordination and control. Within 45 seconds of the initial strike, fires had spread from primary impact zones across key sectors of the facility. Cables, wiring flared, tactical control panels incinerated. Every secondary blast in the smoke marked another transformer substation failing, another combustible oil reservoir venting fire. The air inside halls filled with a lethal mixture: dense, carbonized smoke burning dielectric oil, superheated gases, and showering sparks. Somewhere in that chaos, the threshold was crossed. The vapor concentration reached critical limits, and electrical arcs triggered a full-scale ignition. The facility ceased functioning as infrastructure and became a massive thermobaric weapon, tearing itself apart. A fireball climbed 50 meters into the night sky, trailed by a column of dark smoke, visible for kilometers. The shockwave shattered windows in nearby sectors, shaking the ground like a minor earthquake, sending glass and dust raining into streets and homes. This was no ordinary industrial fire. It was megawatts of active generation capacity converted instantly into thermal energy, heat, and shockwaves. Each secondary blast marked another asset, another major system failing. In under 5 minutes, a strategic asset built over years and costing millions lay reduced to a charred frame of steel and concrete, cables dripping molten metal, destroyed by 2 missiles with a joint mass of 320 kilograms. The city went partially dark. Hospitals engaged their emergency generators. Entire sectors lost water as electric pumps failed. Communication networks glitched or dropped offline. Transit grids, elevators, and basic power died. Tactical lesson was both clear and brutal. No enemy power node, no matter how massive, how deep inside sovereign territory, or how many years it took to build, is beyond reach. In this conflict, the electrical heart, kind of an urban center, is stopped not by bomber fleets or a week-long heavy bombardment, but by 2 guided rockets and a single button press. Transmission terminated.